Oh, there was no doubt we were living through a revolution. I certainly experienced it as such, internalized it in that way. When the paper by Avery, McLeod, and McCarty came along, I didn't use the phraseology, but my exclamations were equivalent, saying this is the dawn of molecular genetics. Because for the first time we could have a biological assay for the genetic activity of an external molecule. So that publication, next to Francis Ryan, were the molding effects on my career. Was talked about quite extensively around the department at Columbia. It turns out we had a couple of people who were important liaison. Alfred Mirsky, who has been remarked on as having been an inappropriate critic of Avery, McLeod, and McCarty. I don't think it was inappropriate, but it was certainly a severe critic. Was also the greatest herald of the story, so we would hear about what was going on at the Rockefeller Institute on the other side of town as if we had been at the same institution. But also Harriet Taylor was a graduate student working with L.C. Dunn, had become interested in it as well, and she in fact went to do postdoctoral work in Avery's laboratory shortly after that time. So we had very close information linkages to the research that was going on there. We were very well informed about it. We reacted to it. There was a lot of critical dialectic, but it was not something that could be ignored. It was the most exciting thing that had happened in many, many decades, and was precisely because it was so important, that is the identification of DNA as genetic material, that I empathized with the view that it should be subjected to the most critical examination. It was too important an issue to just accept casually. So as long as the debate was alive, that was the way the scientific method operates.
It has come to our attention that a mysterious force is loose somewhere in outer space.
The mysteries of creation are there.
Up in the sky?
Up in the sky.
The moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
I think truth is good for kids. We're so busy lying, we don't even recognize the truth no more in this society. We want everybody to feel good. That's not the way life is.
Demonic chapters shall be captured by kings through the storms of days after, and to the earth from the sun through triple darkness to blast you with a force that can't be compared to any firepower, for its mind power shared. The brainwave causes vessels to circulate like constellations reflect at night off the lake. Word to the Father and Mother Earth, seeking everlasting life through this hell for what it's worth. Look, listen, and observe, and watch another sea cycle pulling my peeps to the curb. Heed the words, it's like ghetto-style proverbs. The righteous pay a sacrifice to get what they deserve. Cannot afford to be confined to a cell. Brainwaves swell, turning the desert to a well. Experience the best teacher. Thoughts will spray like street sweepers. Little daddy street preacher, illustrious feature. Narrator you select, accompanied by deck, plus the DJ you respect. The 7.5 combined over the front line. The 10%ers promoting slander in the airtime. Bear in mind, jewels be the tools of the trade. Sharp blades, heavenly praise, and dues are paid. Above the crowds, above the clouds, where the sounds are original. Infinite skills create miracles. Warrior spiritual, above the clouds raining down, holding it down.
Yeah, I leave scientists mentally scarred. Triple extra large, wild like rock stars who smash guitars. Poison bars from the guards, bust holes in your mirage. Catch a charge, shake them down like the riot squad. Invade your zone, ruin like ancient Rome. I expand the universe and return to Earth to claim my throne. The maker, owner, plus soul controller. Ayatollah, rest in the sky, the clouds my sofa. Stand like Colossus, regardless to whom or what. Numerous attempts in my life, so who to trust? Who but us? To supply her with the fire, the burning truth. 150 absolute proof on the mic like Moses spoke in Golden Scribe. Survivor of the oldest tribe whose soldiers died. I know the 5 families, we shed tears and mourn, but our hands are on the ammo cause the battle's still on. Sound the horn. We come rumbling through the function. Precise laser beam technique to touch something. When we die hard, they build a monument to honor us with. Humongous effect in the world, we could have conquered it.
Above the crowds, above the clouds, where the sounds are original. Infinite skills create miracles. Warrior spiritual. Above the clouds, raining down, holding it down. Above the clouds, where the sounds are original. Infinite skills create miracles. Warrior spiritual. Above the clouds, raining down, holding it down.
Good morning, everybody. Good morning. Let me get my volume all good here in my head. Testing 1, 2, test. Give me a little more there. Thank you. Good morning, everybody. Welcome to the show. This is Gigaohm Biological, a high-resistance, low-noise information brief brought to you by a biologist in Pittsburgh, Pennsylvania, coming to you live from my garage. I am very happy today to be moving forward just a little bit at a time, just incrementally, a little bit at a time. And we are still kind of fighting this little, narrative about a social media that's real and a politics that's real and a national security state that's real and does real things with real people that we see in front of podiums. And it is essentially like looking at the video that you see here. If you see Tulsi Gabbard at a podium, that's really what you're looking at. If you see some of these people from Britain in front of a podium, that's what you're looking at. If you see that lady from the EU in front of a podium, this is what you're looking at this stage, ladies and gentlemen. The transition has already essentially occurred, and now it's just a question of whether we will wake up while the legal structures that still leave an opening for us still exist, whether we can use those to work together with our children to leave the trap before the doors are closed forever. I think one of the reasons why biology is so important is because there was a core group of people from the very beginning of this little thing that thought it was going to take about their lifetimes to accomplish. And it's turned out not to be a very good, accurate timeline. And in fact, it's going to take a lot longer. They grossly underestimated the task at hand. But at the time when this, whole plan was hatched out, I would suggest to you that the timeline was about 30 or 40 years. And it's turned out it's going to be a few more generations than that at the very bare minimum for them to even get a rehearsal over. And so this is really an exciting time to be alive because some of these players have been already taken off stage by, our almighty, in heaven. They've already gone off to the, sunset in the sky or whatever you say, whatever these people have done. They're in the afterlife. They're dead. And as they go away, the people that they leave behind are going to be woefully underprepared to sustain the illusion that these people, because of a national security priority, have put in place for 20 or 30 years now, behind the scenes, and now on TV, and then on newspapers, and then in Time Magazine, and then in Rolling Stone, and now we have governance by podcast, where all of these myths are being doubled down upon, and all of these sort of, let's say, mentors are trying to hand off these myths to a whole naive population of people that will go on running in these hamster wheels for long enough for the goal to still be achieved. But this is not where they wanted to be. It's not where they thought they would be. These people who put together these ideas in the book Man and His Future did not think that in 2025 we'd be where we are. By 2025, they thought we would already be past this, and we would already know all of the ways that, we could potentially improve and genetically engineer the human species and target a particular thing in the future, like high intelligence or telepathy or telekinesis. I don't know. These people at this time, when they wrote this book, really thought that by 2025 there would be some science fiction shit going on. And it's not the case. But understand that impetus morphed into a national security priority where all resources, including scripted actors, were bent on changing the population into a experimental animal status in order to crack a puzzle. And they never thought that they would need this many. They thought maybe a few hundred would be okay. Maybe it's going to be a few thousand. But they never in their wildest imagination thought that they would need all the genomic data available on Earth that they could possibly collect. And now think about that task, because that task is not simply writing things down in a notebook and having a notebook for every person and then a big library full of notebooks that you're then going to use to crack the puzzle. It's about assembling a genetic data set that is electronically accessible enough so that a machine learning algorithm can process them as several instances of the same pattern. That's exactly the same way it was done with millions of games of Go or millions of games of chess. And the complexity of the problem would dictate the number of iterations that would be necessary for a sufficient pattern to emerge. And so that theory is possible to apply to such a problem as the human genome, such a problem as a bacterial genome. But heretofore, applying that to these codes hasn't worked. And so there's something that isn't being admitted here, and we're going to have to go back far enough in history and the history of these ideas in order to find where things, people just kind of started to just say, yeah, never mind that one, and, never mind that for now, and here's a ship in a bottle operator here. We're just going to assume that we're going to figure that out at some point. And then here's another ship in the bottle operator over here that we're also going to figure out. We'll just put it on the to-do list and assume that we're going to get that answer. And from a biological perspective, that's very dangerous because the central dogma, DNA to RNA to protein, is a horrible simplification that does in no way, shape, or form any justice to the system that it purports to summarize, nor does it do any, sufficient real arguable evidence for the idea that supports evolution. And so we're really in a crucial place in the history of humanity where, again, this pondering of who we are as a species, pondering who we are as people, pondering who we are as individuals and families, and how we want to think about ourselves as communities, this is all being distorted on purpose, and it's being distorted on and by our use of social media. So sooner rather than later, I will be off of social media completely. I've turned it up a little bit on X. I'm just going to make that place, it's awful. And I'm going to behave not awfully, but awfully there, because I think it's an awful place and people need to realize that it's an awful place. And so I think it's all terrible what they're doing there and what kinds of traps people have fallen into, thinking that, that interaction is real, that putting time into that platform is real, that trying to make friends or win arguments on that platform is real. The only thing that platform is a gigantic waste of time. And more importantly, you're training their algorithms, their chatbots, and you're giving them ideas that they can make Substacks on and use a chatbot to write a Substack on and then dupe another 100,000 people. You got to stop interacting with their platforms and start creating things on your own. And that's really the truth. And I'm not saying that everybody needs to have a PeerTube, but I think you need to clearly see the value of it and clearly see why maybe high schools should have PeerTubes and hobby groups should have PeerTubes. And you can just take the platform and make it what you want to make it with, open source videos that you get permission to repost there. You can create all kinds of libraries and archives that are completely independent of and do not need the personal data of their users, and at the same time can be shared in a very organic way, like email or even a phone text message where you send the link. And so this is really a crucial time where we can get together with our kids and see this as a way forward, this as a way that's not in the system, but parallel to it, taking advantage of all of the great things about the internet and the ability for us to all connect. Just like ham radio could probably be ruined if we didn't have the bandwidth to use as we will, but instead it was all commercialized and carefully controlled and encrypted. So I don't know what to say other than I'm trying to make that effort as best as possible, and all of these streams are still going to mesh in terms of what their focus is and what the direction we're trying to get to, what we're trying to accomplish. And so this is titled History of Pseudobiology 432 with the intention of it being a new series. Maybe it will even morph into a course at some point, but first, the course material really needs to be charted and identified, and that means that we just need to get a number of different histories and accounts of what happened, and how this transition from the 40s or the 30s, 40s, 50s, 60s, what happened with physics and biology there is really a crucial story. I've got about 10 books on my bookshelf. I'm in my fourth one now, that kind of recounts the transition of these biologists these physicists to biology. One of my favorites is called Phage back. I can't even remember them all now. Is it even upstairs again? Maybe I took it upstairs again. Sorry. Yeah, I think I just took it upstairs again. But there's another one that I was also, oh no, here it is. Sorry, it was here. Phage and the Origins of Molecular Biology, a very fantastic book. It is a collection of invited essays where these people all wrote about what they contributed to or learned from the work of Max Delbruck. So it's really a really cool book. And I highly recommend that you get yourself a version of it. It was published by the Cold Spring Harbor Laboratory in 1966, and it's got this nice picture of Max there. It's a sweet book. And it is very enlightening into what these people found and what they didn't find. And what I think you will come to the conclusion of is they found a very complex, if not irreducibly complex system within biology, within bacteria, within phages of bacteria. And so it's a really spectacular insight into, what happened after these guys were off the stage is something very weird. It's like a pivot to animal viruses without ever really figuring it out in the bacteria, without ever really understanding how it works. And a lot of these people being resigned to the idea that we might not be able to figure out how it works, and certainly not if we kept focused on this DNA thing. It's a really curious thing. There's another one of those books about the same time period in America. So there's a lot of, and it is in America, there's a lot of history out there that needs to be well understood. And, it's good to have accounts that of these stories that overlap. So that's the kind of stuff that I'm trying to do in the background. I am a slow reader. I take a lot of notes, so I'm slow, but then I make big progress. Sometimes I'll sit down for 4 or 5 hours a day and get one book done in a couple days, and then other days I'm not reading for a long time because I'm reading these smaller papers, of which I'm also digesting a lot now too, because I finally have a really idea of where I want to go with Biology 101. And this History of Pseudobiology 432 is kind of the flip side of it, in the sense of the history of science is extremely interesting when you think about theories of the solar system and theories of astronomy and theories of physics and astral bodies and this kind of thing. The way that people work that out with observation and careful measurement and that kind of deal, I really like that a lot. The history of science is really interesting. And so therefore, how we got here with the bookshelf of assumptions that have not really been adequately justified from an experimental basis, but still fuel our whole assumption set, is really extraordinary. And so I think this is how we go forward. I might start a new channel, but if you're on the PeerTube app, it won't matter. It'll all just show up in the app itself. I still do believe that this is for all the marbles. I think that's why there's a fake anti-vax movement in America. I also think that's why the Human Genome Project has been so consistently exaggerated in both its success and sort of its breadth and depth of knowledge. They constantly repeat that, oh, now we got it. No, now we really got a new milestone. And they've said that throughout Francis Collins's career, and he's even joked about that at certain, with certain audiences during certain appropriate times, where these people are either, sufficiently on board or sufficiently naive not to understand what he's actually admitting. But what he's actually admitting is that the Human Genome Project is kind of an illusion. It is nothing more than a set of restriction enzyme maps that were considered kind of landmark maps that, how much, to what extent is the human genome, to be generalized across individuals. And what they learned from the Human Genome Project, the more that they made these restriction maps, the more they realized that there was too much variation for them to conquer with this primitive technique. But that was the only technique they had. You had to cut these large pieces of DNA into tiny pieces that could be amplified by bacterial culture to a sufficient quantity and purity so that they could be read as molecules, with lasers or with light or with some other means that only a pure enough, strong enough signal will give them a reading. And so the whole error rate in Sanger sequencing, as I understand it, will be the relative purity of that the relative purity of the fragments that are made, and whether or not the original PCR product is really being amplified is the one that you wanted. There's lots of stuff there that, of course, people say that have been methodologically conquered, but being able to make better photocopies of Chinese encyclopedias doesn't mean that you're getting better at reading the Chinese encyclopedia. And that is the extreme preposterous nature of what we have done with regard to teaching children and teaching me as a grad student about what the implications of our understanding of DNA are. And they are not what is being taught in university. It's simply not true that we have already sequenced full genomes and we can just kind of walk you through the list of genes and what's there and what's not, and we know what's useful and what's not, what's extra DNA or junk DNA or any of these other things that people have said, even though at the same time we understand that in the limited sort of work that we've done in vitro with cell cultures and with gene expression and using vectors to express genes in mammalian cells or in bacteria, we have already discovered that there are all sorts of gene sequences that can be used as initiating signals, enhancing signals, timing signals, temporal delay signals. And so all of these things are still hidden clockwork in the genome that even 10 years ago people didn't really understand to what extent these things could be interactive, and never mind across genes and across protein expression timeframes, across tissue dependent mechanisms like the RNA dependent the ribosome, and it's dependent on RNA folding. So the whole machinery that is doing the translation from RNA to protein is a combination of RNA and protein that everybody in biology seems to want to ignore, even though it's the most important transition, because supposedly DNA and RNA are just kind of mirror copies of each other, in the sense of RNA copies one active strand of the DNA and then gets sent out of the nucleus, kind of be used as a disposable copy. And so the magic actually happens in the ribosome, but the central dogma rarely even mentions that machine. It's so bizarre because, it's as far as my understanding goes, it's really weird, but mitochondria have their own ribosomes. Not only do they have their own DNA, but they have their own ribosomes. It's strange because on one hand, we're told that mitochondria are just kind of the leftover endosymbiotic husks of early bacteria that now just serve the purpose of providing a proton gradient from which ATP is generated. But it just feels a little weak. It just feels a little weak to me. And that's the gut basis that I'm going on. And then that combined with the fact that I think I have at least 15 books in this room that prove that intramuscular injection is just a dumb idea from the late 1800s. I know for sure from my professional experience as a neurobiologist that transfection of healthy humans was a crime from the start of the pandemic onward. And anybody that tells you that they were a whistleblower and had any experience at all with either vaccinology or bioethics or maybe even anti-vax or public health freedom or I don't know what, anti-mandate stuff is full of baloney, because it's very, very simple. It's an old technology that's been renamed, and they are the only way to explain why there is no one in the public sphere that has been able to say this for 6 years is because a national security state operation has been in charge of controlling this narrative so that no one would ever use the word in a place where it mattered, and certainly the word would never catch on. And this goes back to the Human Genome Project as well. The only way that we're ever going to be able to get any useful information about humans is to use humans as the experimental animal. There is sufficient biological difference and uniqueness between species, as never mind across vertebrates, that anything that's learned in one of these model organisms might have or might not have a molecular counterpart in its, let's say, temporal conspecifics and temporal peers. And when I say temporal peers, I mean everything on Earth right now is a temporal peer of one another. Our blue whales are our temporal peers. They, as far as we can tell, blue whales haven't always been on Earth. As far as we can tell, they might have not always been on Earth. And so there are temporal, I'm just going out there here and trying to get you to get into the right page with regard to where this stuff fits in. Because we can know. That's the trick. Don't think for 1 second because social media has convinced you that you can't know. You can know. You just can't use social media to find it, at least not without a lot of different outlook and skill use. And you don't need to. There's books and stuff like that. Although the internet, if you use it right, you use it with intention. Go to Housatonics Archive. You go to, Wikipedia. You go to, download a book, a PDF of a book, and make sure that it's this is all possible uses of the internet, but social media is not good for you. RNA cannot pandemic autism is a meaningless word by design. And so I've been asking you to consider the possibility that for a long time we have been playing sort of a game with what we believe versus how we act. I think I have for a long time believed that it was a two-party system that was actually one party putting on a show, agreeing to have dinner with each other, but then arguing in public about different things. And to a certain extent, it made sense to me. But as sort of my experience with current American history over the last 53 years, certainly over the last 35 years, I've really come to understand that I haven't really taken that to a logical conclusion. And if that's really the case, then shouldn't we also assume that the people that are elected are already kind of okay with everybody? Shouldn't it be that that's the reason why, right, that we are where we are? And so we put a lot of energy into things that we probably don't need to put energy into anymore. And that sounds scary at first, but actually it's not, because once you realize that if none of us voted, they would still elect somebody and they would still make the drama on TV, and maybe they would even tell you that most people still voted even though you know that nobody did. That's the extent to which they control social media and the mainstream media. I want you to hear that analogy again. If all of us, and we could verify it by walking down the street, and everybody that puts up a white flag has decided not to vote, and everybody in Pittsburgh was flying a white flag, they might still tell you that the president was elected and everybody but Pittsburgh voted, or, you know, a lot of people voted but put up a white flag anyway because they were afraid of what their neighbors would think. A lot of people mailed in their votes and then they put up the white flag anyway. So you see what I'm saying? There's lots of contingency plans. There's lots of scripts here. The most important thing is, how do we get out of this? And maybe one of the ways to get out of it is to elect people that you trust. I don't know. But I think right now, anybody that comes into Clearview is a need-to-know scripted actor, a need-to-know basis scripted actor, meaning they don't know what's coming. They haven't been told everything. They don't know who all the people who are in on it. And that's part of the reason why they can remain controlled, because they're each sort of run by a different handler, and they have no idea whose handlers are working with whose handlers. And that's really what makes this so magical. But make no mistake about it. If you want to know what's going on, you got to ask the right question, and then you got to come up with a plausible answer. And I don't think very many people have a more plausible answer than the Human Genome Project when it comes to why would it be that America would be run by a false two-party theater? Why would it be that maybe world powers and weaponized piles of money are fighting over control of America and its infrastructure and its military and its government? Why would people take that so seriously that they would take control of elections by taking control of what essentially all the citizens in America know? It's the Human Genome Project. It's about getting rid of the FDA. It's about all these things that from the beginning, specifically the American system is really not set up to allow. And it's a unique system in that way. That's why in Canada and in the European Union, they're going to push forward with digital ID, and it's going to be almost irresistible for the citizens. That's why they've had this plan for a long time, right? And so America will be one of the last places where, you know, the internet will be free, or that anonymousness will be tolerated or something like that. And then maybe there'll be even a rift between whether or not Americans can go on the internet or be seen on the internet in certain places or in certain locations or with certain internet providers, because again, you know, we need to control the identity of people on the internet. And all this will do, like the guy from Dune said, was, you know, if you turn your intelligence and your thinking over to machines so that you can be free, all that's going to do is open you up to being enslaved by men with machines. And that's what's happening right now. Unless we are the ones who are creating the network, you know, creating the community, then it's always going to be controlled. And that's really where we are. This Human Genome Project is going full tilt now. And any chance of knocking it off of its tracks is now, in the next 10 years. After that, I don't see that we can make it. I don't really see that we can make it. So again, there's nobody in front of you explaining why this line is not level. There's no one explaining to you how it is that we lost control of pneumonia for a couple years and then just seem to get control of it again. There's no one trying to frame this in the context of the opioid crisis. There's no one trying to say anything about supplementary oxygen. They just want to talk about, I don't know anymore, mostly the COVID shot. And so it is kind of a disaster right now. It's kind of a worst case scenario, I would say. I think that's true. We do have a worst case scenario because there is a fraud at the HHS secretary's desk. There is a fraud at the director of the NIH. There's a fraud at the Oval Office. We are essentially being governed by actors, or at least that's what they want us to believe. Even Tulsi Gabbard, are you kidding me? I mean, she's exactly as adult as like Barry Weiss. They're just not, they've been scripted for so long and prepared for their role for so long. They are not natural people. They don't have a natural explanation for their flaws. They don't even have any flaws as far as they know. And you can see that with all of these people. They don't have any flaws. There's no edge to their behavior. They're not real. They're acting. And you can, well, anybody that's been in the room, you can see there's no script here. I don't know where I'm going with this except a general feeling of what video I want to discuss. But when I see these slides and I think in this stream, it's just something that comes out. And none of these people are doing that. And they've never been doing that. They are improvising within a script provided to them by this national security state that needed to manage a problem, right? A specific problem. A specific problem that had been coming since I graduated from high school in 1990. This bump right here. And this biological signal was something that the national security state planned for, to use. And it is likely that 9/11 was something that was in this time frame as a biological attack, which would have been one of those stepping stones toward removing the sovereignty from American citizens by first maybe starting with the sovereignty of the American military. Not that dissimilar to what they tried to do at the beginning of COVID as well. And so this was an anticipated signal that the national security state intended to use in order to solidify its control of the civilian population. It's a national security issue. And so when you hear these people that have been put in front of us to say it's the DOD, they're not really saying it correctly, because the Human Genome Project would be the DOE, just like nukes is the DOE. And so something happened on 9/11. I'm not sure what happened. But it is extremely interesting that Joe Biden was on television talking about bioterrorism the day before. It is extremely interesting that the book Big Shot AIDS Vaccine or whatever it was came out like the day before. It's just really, really interesting. And so this anticipated rise in all-cause mortality was not overlooked. It was used.
You want to weigh in, they can.
Now, yesterday I was watching this TWIV with you, but I actually didn't have time to watch the crucial part of the video that I wanted you to see. And that's good, because it's a good introduction to the David Baltimore interview, which we will not have time to finish today because I will probably collapse if I stand here for the whole video while I also stop it to talk. But I will try to do quite a bit until I need to stop for lunch before the basketball this afternoon. So this is the guy from Harvard, right? He's the head of Harvard Virology, and he's being pested by Vincent Racaniello. Now, Vincent Racaniello is the kind of the all-star student of David Baltimore, very famous for having been on the paper where they used a DNA copy of the polio virus and transformed a set of cells, and it packaged, I guess, more virus or something like that. They were the ones who invented the synthetic DNA cloning of viruses. Yes, Vincent Racaniello and David Baltimore. And David Baltimore died last week. So it's important to collect the videos of David Baltimore, make sure they're not lost, because any teaching moments that he might have had, any special insights or, unique analogies that he might have had could remain an insight into key biological ideas that maybe no one will ever come up with again. And so it's a valuable resource that we have all of these videos of David Baltimore. On the other hand, maybe these videos will be like the videos of Elon Musk, where this seemingly smart guy will say nothing of interest and nothing of report and nothing profound. That's also very possible. So again, this is first to illustrate that the myth of virology is in danger. The people that sit at the chair of Harvard biology or virology at Columbia, etc., these are the people that we would potentially be discussing RNA cannot pandemic, discussing that intramuscular injection might be a dumb idea from the late 1800s. And I want to hear I want you to hear what they think about these ideas, because we were set up on the health freedom side to either believe in gain of function or to believe that there are no viruses at all. That's the extreme version of the Scooby-Doo, where it's a lab leak or it's a natural virus. Because in that Scooby-Doo mystery, the lab leak is still just a natural virus that was growing in the lab. And in our version of the Scooby-Doo, there are no viruses in some people's minds, and there are magic viruses that are gain of function and could kill billions of people in the theoretical mind of others. And so if you recognize the cognitive fracture that they have brought us to, it's actually much worse than I've ever been able to explain it, because it's not a natural virus or a lab leak. It is a natural virus or a lab leak embedded in two absurdities: no virus or a gain of function mystery virus with extra properties that are doing extra damage. And yet when we were in this trap, and as you're in this trap, it doesn't feel like that, but actually it doesn't matter where you went on the skeptical spectrum, you were lost. And the easy choices were a natural virus that got out of a lab or a natural virus that got out of a bat cave. And so like 70% of the population is here. And many people have been chased, coerced, or goaded into taking one of these two absolutely absurd positions, which makes this guy sitting firmly in the yes, there are viruses, yes, vaccines work, there's no questioning this, making him feel very confident in his position, but nervous because he's talking to one of these Godfather dudes, Vincent Racaniello. Now listen to this discussion. I'll try not to interrupt it, and I know that's kind of a joke, but I promise.
No, but in general, my research program has largely been centered on using protein engineering as ways to tinker with proteins in order to kind of direct or redirect the immune response to understand how we respond to pathogens, in particular viruses. That's what we focus on. And so what I'm very interested in trying to understand is what is the way that our immune system sees a pathogen and how antibodies are made to it, and how can we use that information to potentially guide next generation viral vaccines. And one thing that we're interested in trying to understand is once you make an immune response to a particular pathogen, how does that pathogen sense that immune pressure, and how does it evolve away from that immune pressure, and how does viral escape happen, and how does viral evolution happen? So we're trying to use that information to ultimately try to design better vaccines or new vaccines against some of the most pressing viral diseases around.
So as you know, the head of HHS doesn't believe in vaccines, right? He doesn't believe in infectious diseases, in fact. So do you think there is a future for new vaccines?
I just said I was worried about what was coming out of your mouth.
I know it's a hard question.
But it's an important one. And in all joking aside, I absolutely believe that there is a path and a necessary path for new vaccines to be developed. I'm a strong believer in vaccines. I'm an advocate for vaccines. And I think that the work that we're doing can certainly be used as blueprints for approaching potentially new pandemics that could enter into the human population. And so I would vehemently disagree with what is currently being put out.
It's really cool, right? It's almost like he's testifying, and he's, I believe in the virus. I believe in novel viruses. I believe that the vaccine saved millions of people, and I believe that another virus could come again. He's actually, not even asked to, but he is reciting all the tenements of the faith.
By our government, and am a strong believer in vaccines and the importance of making sure that our communities are well-versed and knowledgeable in what vaccines can do in terms of protecting them against viruses and other diseases that could have other rather severe consequences.
It's almost like he's being coerced right now, like there's some dude behind the curtain with a gun. It's crazy. He wants that microphone back. What a guy. Remember yesterday we were already laughing about them clapping. Wow, it's remarkable.
Great audience, really good. Thank you.
Great
I love
audience.
it. I feel like I'm Johnny Carson. I see so much cool technology.
Now, what I want you to think about is the fact that this is now one of the virology experts on Earth. He calls himself Earth's virology professor. He streams hours and hours a day with other virologists. And so just listen to the way that he talks, listen to the questions that he asks, and think about whether that suggests that this guy knows anything about molecular biology or just really knows what he thinks he did in David Baltimore's lab, and that's it. Everything else is he's read some virology books and has taken every single word in those texts for granted. Never questioned them, never thought about whether there's any contradictory things being displayed here, whether this jives with what he understands about the central dogma. Nothing like that, just accepting it and the Baltimore scheme, all just, yep, that's the way it is, because I worked for him. This is an amazing little discussion. I'm going to try and get through it. Gee, I can't.
That can be applied to vaccines, and it makes me sad in a way that we have a leader who doesn't embrace that, right? But I agree with you. I have great optimism, and we're going to get past this. We will. We have to, because the alternative is much too much suffering. All right, so I read a couple of your papers, and it was good to put me asleep. Just kidding. You're good to joke on. He's a good jokester, right? Oh, you know this already, right? Oh, okay, I didn't know, because I'd never met him before. So here's one. Conserve sites on flu H1H3HA recognized by human antibodies, right? These can be used as a template to design a vaccine that elicits them. So I always wonder how you could do that. So you know which antibodies are important, which epitopes induce them. How do you focus a vaccine on those?
Yeah, so that is a great question. And so what we often do is look at how, in that particular paper that you are referring to is actually, the lead author on that was Daniel Maurer, who was actually a virology graduate student who was recently graduated and is now at Moderna doing research there as a scientist. And so one thing that we're interested in doing is, as you pointed out in that paper, is that we identified human antibodies that recognize particular parts on the influenza hem. Yeah, so
and it was good to put me asleep. Just kidding. You're good to joke on. He's a good jokester, right? Oh, you know this already, right? Oh, okay, I didn't know, because I'd never met him before. So here's one. Conserve sites on flu H1H3HA recognized by human antibodies, right? These can be used as a template to design a vaccine that elicits them. So I always wonder how you could do that. So you know which antibodies are important, which...
And I think the most important thing to point out here is that, again, we're having a discussion in 2025 about the immune system, and the primary model of immunity and the primary measurement of immunity, the primary sort of knob that they are trying to fine-tune is our understanding on how antibody specificity is produced and how you could coerce antibody specificity. Now, it's interesting because a discovery by the guy by the name of Susumu Tonigawa, in I believe 1983 or 1984 is when he got the Nobel Prize for it. He discovered the genetic mechanism by which infinite variability in the variable region of antibodies can be generated by gene reassortment and somatic mutation. It's a single paper written by a single guy. He's really a badass. And what's cool about that is that mechanism is sort of assumed to only be unique for B cells, which I think is likely a national security myth, designed to make you think that, genes and gene expression aren't really that complicated, except for in this unique case of antibodies. And what I find so fascinating about that is that's also the unique biological conundrum that all these virologists and all these immunologists that are paid by the national security state seem to be stuck in. Even though there was a Nobel Prize awarded in 1980-something for the genetic mechanisms underlying the infinite potential antibody diversity available to everyone, which is, of course, probably the main molecular reason why the antibody patent paradox finally came crashing down in 2020 after a Yale Law School review paper was cited by the Supreme Court. So this is crucial to see, because this is a Harvard virology retreat where all the acolytes will go on to be virologists at virology departments around the United States and around the world, potentially. All regurgitating this half-baked nonsense about some kind of high-fidelity understanding about a molecular world we can only probe if we create large quantities of those molecules and then measure them indirectly. And so how in the world do we know what's going on at that size scale? We simply don't.
Epitopes induce them. How do you focus a vaccine on those?
Yeah, so that is a great question. And so what we often do is look at how, in that particular paper that you are referring to is actually, the lead author on that was Daniel Maurer, who was actually a virology graduate student who was recently graduated and is now at Moderna doing research there as a scientist. And so one thing that we're interested in doing is, as you pointed out in that paper, is that we identified human antibodies that recognize particular parts on the influenza hemagglutinin in particular. And the hemagglutinin and the vaccines that we have against flu are largely, from year to year, varies quite a lot, but in terms of efficacy, and it's no greater than usually about 50 to 60% efficacious from year to year, and then sometimes it can be as low as 3%.
And so keep in mind, he hasn't said why that's related to the hemagglutinin molecule yet.
And sometimes not effective at all. And so what we're trying to do is to understand from those natural those vaccines that are used routinely, the seasonal vaccines, or through natural infection, the antibodies that are made in response to those, either natural infection or the vaccines. And what we did in that paper was to understand where these antibodies...
What we did in that paper was to understand where these antibodies, period. Really? What we did in that paper is understand where these antibodies, please, tell me more.
Bound on the hemagglutinin, use structural biology to determine their epitopes. And once we understood where these antibodies were binding, we then further characterized these antibodies and what we were interested in terms of how broadly could they bind to other different hemagglutinins, or how potent were they in neutralizing the virus. And we use those as metrics, as ways to say, these are the types of antibodies that we want to potentially elicit by next generation viral vaccines, because they have quote unquote superior quality than the other antibodies that are made by our standard seasonal vaccines or through natural infection. So we're trying to fish out those needles in the haystack, if you will, that are the best, baddest, broadly neutralizing antibody, which I don't often want to go after, but at least to some...
Which are all generated by a Nobel Prize winning mechanism, or a mechanism the discovery of which was awarded the Nobel Prize, where a nearly infinite variability, a nearly infinite possible variable collection of epitopes is possible to manufacture in B cells. So think about this hyper focus on what just happens to be a really lucky thing, right? Because these cells are freely available in blood. If you wanted to study any kind of phenomenon like this, where a huge diversity of genetic variance was being generated in the protein output of a set of genes that itself was not really varied, that would be a pretty hard thing to study in any other tissue. If that was happening in any other tissue on any other scale, in any other context, it would be almost impossible to detect and measure and monitor. But in the immune system, because of the nature of the way the immune system behaves, and because of the unique nature of what B cells and their plasma cells do, We have this one kind of, like rudimentary magic trick that we can do where there seems to be some specificity. We can probe it, we can measure it, we can reproduce it. But the specificity is always emerging from this galactic bouquet of possibilities that's each all dependent on our unique genetic background. And so he's still talking about viruses evolving relative to humans as basically two teams instead of a galactic diversity in humans and a molecular diversity in nature that can't be quantified, never mind called influenza as a separate entity. It's probably not even really that accurate. So it's a remarkable place for us to be right now, where there are people who are absolutely convinced they are right because the books they have read are really heavy. And the books that they have memorized are really heavy. And other people agree that those heavy books are important, like the 2-volume Fields Virology or the book Vaccines by Plotkin, Orfstein, and Offit. And as long as they can regurgitate these books, it seems like they really know their stuff. And that's all he's really doing here, is trying not to hit any third rails, trying not to make any mistakes in front of all of his apprentices. And it's going to get painful.
Something that can be used then for a template, because once we recognize on the structural level how this antibody sees the hemagglutinin or the epitope of interest, we then take that epitope and then design strategies for our immune system to only see that epitope. And so we use that.
So they're reciting a grant application because what they're going to do next is comic book fantasy. We're going to design strategies. What the hell does that mean?
One of the approaches that we take is epitope scaffolding. So we take that particular epitope and put it onto something that our immune system has never seen before. And so that the focus can be just on that epitope.
So you put the epitope on something that the immune system has never seen before, but the immune system never reacts to it? So what is that? Wow, that's interesting.
Or an orthogonal strategy that we use is to take that...
Orthogonal strategy.
Stop lying!
Gosh, I hate that phrase.
Epitope that is naturally on the hemagglutinin and use glycans or sugars as a way to sterically block the ability of the immune system to see the...
So all of these strategies require them to produce proteins which are identical and then to measure an effect of that quantity of protein relying on the idea that it's pure. Therefore, the signal will resolve against the noise. It is the exact phenomenon that all these physicists use, and it's the exact phenomenon that we go over in Biology 101, the first few lectures that we did where we were working on this book, and where I just kind of stopped. But this book, What is Life and Mind and Matter, this has a whole discussion about how physicists are by definition taught to think about particles in quantity, and that it is signals that emerge from the behavior of the quantity that allow them to imagine and theorize what's happening at the particle level. And so that's not that dissimilar to what we are able to do with the technology provided by the Human Genome Project. We make a lot of synthetic pure DNA, and by making a lot of synthetic pure DNA, it is possible to measure it chemically and sequence it. That's about as far as we've gotten. We've gotten really pretty competent at making copies of DNA in sufficient pure quantity that we can sequence it. That's about it. And making that cheaper and more convenient, or maybe more reliable, has really been the last 30 years, all with the idea that eventually we were going to figure all this stuff out. It would just be an exponential thing. It's only 10 years from now, when nobody's going to die anymore. You can upload your consciousness into the computer and you can live forever. That's the time frame that they were on when they were writing this book. And so the mentors of the people that are currently trying to run the clock out, hoping that, they're going to be able to successfully hand this off to the next generation, it's not going to happen. We can break this right now because academia is not ready for the truth. They can't handle the truth. And Gigaohm Biological and a few other people, I think, can help us teach this. If we can just reach a few hundred high school teachers, think about that. If we could just get a few hundred high school teachers to question the central dogma in a useful way so that we raise a generation of children that can successfully challenge that, it will be remarkable. What a remarkable way to try and plant trees under whose shade we will not shelter.
Other parts of the hemagglutinin that would otherwise distract from that particular epitope that we're interested in. So we use a lot of, as I said in the very beginning of this, protein engineering as a way to tinker with these proteins, as a way to trick the immune system to only see the epitopes that we're interested in getting our immune system to recognize.
And so imagine the arrogance that they think they're tricking the immune system, that they think they know enough about the immune system to trick it.
Stop lying!
I mean, it's, wow.
It's interesting you say 50% efficacy, right? So Daniel Griffin always says, he has a patient who is hospitalized with influenza, and he say, hey, doc, I got the flu vaccine and I still got sick. And Daniel will say, but did you die? So you may get sick, but it often protects you. So you would like broadly neutralizing epitopes because that way you might not need a vaccine every year, okay? So, and there are two places where, there's one main place where you find such broadly neutralizing antibodies, right? Mm-hmm. Which is the stem. Tell us about that.
Yes, so you hit a hot button issue on me for this one.
So STEM is a student in the audience, and they're talking about the hemagglutinin molecule and how it has a stem and a head, not that dissimilar to the spike protein, having a stalk and having this ACE2 receptor where the fear and cleavage site is or whatever. And so it's a very similar narrative. It's a very similar hamster wheel that academia has been put in, I think, by people like David Baltimore. It's a hamster wheel that by definition accepts the existence of animal viruses that are completely independent of bacteria or phages or any of these other signals. They're just animal viruses that grow in us. And we're supposed to accept that on face value. And these people have in fact accepted that on face value because they've read books that say it. And I'm humbly suggesting that if you have been a biologist your whole life and really tried to understand the concepts of modern biology, you will see why there's something really wrong right here, right now. I think Joshua Lederberg knew it. I think a few other people knew it. I think David Baltimore knows that he was actively concealing our lack of knowledge under the guise of certainty and it's just what I did.
In all seriousness, I think that for me personally, I do believe that the stem can be a good target for antibodies that could help contribute to control and protection against influenza. However, I am a huge proponent of the receptor binding site and the head domain. And so I sit on the opposite camp than Peter Palese and others and Florian Kramer.
I mean, is this any different? Florian Kramer is somebody who was on Twitter all through 2020 and 2021 arguing that it was a lab leak. Florian Kramer is supposedly a guy who's on the stem. It's like, it's so remarkable that they have gotten and convinced academia what the important issues are just by funding those people. So you can even hear it in his discussion that he's very careful not to question the premise of his funding, but also to try and, stake out very clear differences between the dogma that funds his lab and what he thinks is true. He's very careful not to actually shake the tree, but just wants you to know that there are other fruit trees in the orchard.
Daniel Lingwood, my esteemed colleague at the Reagan Institute, who also believes that the stem should be the target of next generation influenza vaccines. I have no doubt that they will help as a useful component, but those antibodies are largely important for ADCC or ADCP dependent mechanisms of protection.
Those are antibody dependent cellular toxicity mechanisms. So when the T cells, or the natural killer cells, recognize that a cell is producing a protein that it shouldn't, they can be destroyed. And so that can be an easy way to, stop a respiratory virus, for example. If the epithelial cell just needs to be targeted, then it's all good. And he wants you to believe that that's not a very good way, because then the virus is already doing its work. And so we should try to develop antibodies that stop the virus from doing the infection. But if the infection is happening at the epithelium, which it most certainly is with flu, no matter which epithelium you choose, then the cytotoxic T cell response to the presentation of a viral antigen will inevitably be a non-self protein. So there might not even need to be that much specificity. And that's also an antibody independent mechanism. So there's multiple ways that the immune system can interfere with the free expression of a foreign RNA or DNA. And so this is just absurdity. Again, what he's doing is reciting the dogma that funds his laboratory. He's not reciting something that he knows, he's reciting something that he has learned to accept.
And so those are only after the virus has actually established an infection. And so the first line of defense, in my view, should be those that block the receptor binding site and actually inhibit the virus from actually getting into the target cell before it can establish an infection. And so our efforts have largely been focused on finding ways to direct our immune system to that conserved receptor binding site, because the vast majority of influenzas, except for several of the bat H17s and H18s, use sialic acid as a way to get into a target cell. And that receptor binding site that chelates the sialic acid in order to enter is largely conserved across many different influenza hemagglutinins. So that's the target that we should be going after, in my view, and secondarily should also focus on the stem region.
So the stem antibodies are not neutralizing, you're saying?
No.
And so one of the naive things that you hear here is that he's saying that these viruses that he believes in and calls flu viruses are targeting the salicylic acid, or is it sialic acid? I don't know which one it is. And that's the receptor that they bind to. They chelate it, and then that gets them into the cell. And those regions are conserved. Now, I'm wondering if he's ever thought about the possibility that making antibodies to that would be making antibodies to a epitope that might be related to a self-epitope. In other words, you don't want your antibodies that are anti-hemagglutinin to be really good for your own salicylic acid. And so that concept isn't even on his radar. He is reciting an argument that he's made in a grant and has gotten funded, and therefore has some, financial reason to believe that that's a good idea to stick to right now. But it makes no logical sense, certainly not from a broad biological sense. There's no real understanding here. There's an acceptance of a cartoon and the designing of and writing grants that will confirm that cartoon.
In the traditional assays that are used to determine neutralization, you do not see neutralization with stem-directed antibodies, only with those that bind the receptor binding site.
That's some nice discussion here. So there are conserved epitopes on the head.
Yes.
You're saying, are those inducing neutralizing antibodies?
That is correct, yes. And one thing that I also want to, I don't necessarily subscribe to the one epitope only in terms of receptor binding site or stem. I think we need to think of the hemagglutinin as a continuous epitope, that there have been antibodies that can target various portions of this.
So no one is in the audience is sophisticated enough, and either David Baltimore's apprentice, Vincent Racaniello, is not sophisticated enough to know or understands this as the third rail, is asking whether or not people have the genetic propensity to be able to be steered to produce the same antibody. In other words, let's just think about all the natural ways that you could make my breath smell differently. Isn't it easy to imagine that the same treatments might not have the same effect on you as they do on me? Maybe garlic will make me smell better, but garlic will make you smell like a trash can. Maybe a combination of lemon juice and vinegar is something that I should gargle, but when you gargle, it's something else happens. Now, I know that these are very rudimentary examples, but what I'm trying to get at is that the immune response produced by a human with a unique genetic background and thereby a unique genetic bouquet of possibilities in their B cells is not necessarily going to end up on at the same endpoint, at the same conclusion of that process. It's by definition random, which I think is one of the most beautiful things about it, potentially. And yet, somehow or another, these very high-ranking virologists are discussing the immune system in a way that absolutely ignores the irreducible complexity found in a single example of a human being, never mind the collective population of human beings. Again, it's an irreducible complexity that has been reduced to a comical level on the academic bench. And it is their commitment to that comic level of simplicity that allows them to say, I'm absolutely committed to vaccines. It's just like saying he believes in the stem more than he believes in the head or whatever, because it's all the same level of commitment, the same level of sort of blind faith. It's not any dissimilar to how someone reads the Bible and then believes what they read after reading it several times and memorizing it and quoting it. And I believe that there is a knowledge to know. I do. I believe that you can have a genuine appreciation for what you can't have, what's unreachable, and still look at nature with enough precision to try and understand something about it, to appreciate its complexity. That's not even close to what the Human Genome Project ever thought that they were. The Human Genome Project was the culmination of this imaginary thing that these physicists in the 1950s thought they were crossing over to do, to finally, get the last rules of the universe. And we're not there.
Of the entire hemagglutinin and not just one discrete epitope, and that all of these working together could help control the spread of these viruses or influenza.
So the conserved head epitopes, are they also broadly neutralizing?
So those that target the receptor binding site, what you often trade for potency is breadth. And so those antibodies that are very good at binding the receptor binding site for H1 influenzas, for example, they are broad against many of the H1s, but then can't cross, if you will, to group 2 influenzas like H3s. However, they are extremely potent within the particular subtype of interest. And so
let's just say right here that neutralizing antibodies is a pretty antiquated way of measuring antibody specificity. I don't know if they'll get to that or not.
I could imagine that if you're trying to develop a next generation viral vaccine for influenza like we are, that it's a quite tall order to suggest that you would get one that is universal against all of the influenza subtypes. And maybe a more practical way of approaching it is to have a very good next generation vaccine that targets group 1 influenzas and one that targets group 2, and to use them together as a way to combat both group 1 and group 2 influenzas, as opposed to trying to get one that covers all of them.
All right, and what you said before is you would make a platform to present these epitopes, which is not related to influenza virus at all, right?
That's correct, yes.
Okay. So
So he's developing technologies to present epitopes to see that's all academia is now. It's a stepwise development of technologies which might be able to peer behind the curtain of the human genome and inheritance.
So the best we can do is have probably 2 groups of broadly neutralizing epitopes that generate antibodies, right? And can you get resistance to those broadly neutralizing antibodies?
You can, and so there was some work that we and others have done that when you take these very potent H1 specific antibodies that block the receptor binding site, you can, for that particular antibody, select for resistance and show that even though they are very potent, that resistance can develop quite rapidly, actually. Even after 1 or 2 passaging, you can get resistance mutations that come up. However, the key observation in those studies is that, yes, you can lose binding to...
So again, now he's referencing other people's work. He hasn't done any of that. He hasn't enriched a flu virus to not see his antibodies anymore. He's just seen other papers that have done that.
One of the antibodies that recognizes the receptor binding site, but through structural analyses, you can show that there are other antibodies that still recognize the receptor binding site and the conserved elements of that, but that approach from a completely different angle. And because of that, they are not sensitive to that mutation that escaped the first set of RBS-directed antibodies. And so the idea there would be if you had a immunogen that could elicit...
So he's still running around in this little circle where, 3 monoclonal antibodies might be the trick. Like that lady who was from Canada, was trying to cure Ebola or being tested against remdesivir, where it was 3 antibodies that were doing the cure for Ebola. So it's really, really remarkable how little progress and understanding, never mind what target they're aiming at, is really changing here. And that can only be because of one reason, because this is largely a national security theater. Whether these people know, I doubt it. I don't think he's sophisticated enough to know. I think that if I was to be able to sit down with this guy in a naive situation where he didn't know who I was and start drinking, I think at the second beer, if I started to pivot toward the genome and genetics and inheritance and the experiments that he knows and understands, I would blow him away. In fact, I think one of the ways that I want to spend some of my travel time now is to try and do that, to try and go to like a virology conference and be at a bar, hanging out, and have a bunch of virology kids come up and start talking to me on camera. Because it would be an amazing capturing of how, this whole group of people in this room would probably love to listen to me do stand-up comedy, because I could make them laugh about themselves so deeply.
Antibodies that target from a variety of different angles, all recognizing that conserved site, that the likelihood that you would get resistance to the entire class of antibodies that are recognizing that would be very small.
So, he's still explaining models and he's explaining cartoons with no data.
So even though you can get resistance to one, I don't think that you would be able to get resistance to all of them, because at that point you'd be compromising the viral fitness and the ability of that virus to chelate or bind sialic acid to get in.
So your message
sialic
to
acid, sorry, my bad.
The non-scientists listening is that we're going to have a different kind of flu vaccine in the future.
I think the way it was designed, yes. But in the way that it's going to be administered is going to be the same.
Oh, sure.
If that makes sense.
Yeah.
I just want to make sure that that's clear, that this isn't going to be a new platform or modality, I would say.
I just can't help but mentioning there's this NIH initiative to make next generation flu vaccines, which is just to take virus and inactivate it, just like we've always done, right? And they're saying this is brand new technology that's going to protect against all phyla. Do you remember? Did you hear that? All phyla. What do you think about that?
See, so I don't think Vincent Racaniello understands. I think he's kind of a dope. And I think that's why the loss of David Baltimore is extreme. Because the more people that they don't have which know the script and can improvise within it, the more danger the script is in. Robert Malone can improvise within the script. Kevin McKernan can improvise within the script, but I don't think that any of the people on the stage right there can improvise within their script. And I think if they were exposed to the right people, they wouldn't be able to explain why intramuscular injection is used right now, why that makes any sense from the perspective of the immune system, or even exposure to toxic compounds. We're talking about a paucity of knowledge that is only possible because of the way that academia teaches people. And I would be there just like them if I hadn't grown up with the grandmother that I grew up with, quite frankly.
Do I have to answer every question you ask me?
It's okay.
No, I agree with your incredulousness at that statement.
Well, phyla. Okay. One more paper, then we'll move on. This other paper caught my eye. Antigenic drift expands influenza viral escape pathways through recalled humoral immunity. Okay? So recalled, is that memory?
Yes.
I want you to listen. They're going to repeat the title, and then he's going to try to explain it, and he loses his train of thought, and it's just pathetic. It's just pathetic.
Why don't you call it memory? Is this an immunological thing that you have to have different words? Okay.
No, I agree with your incredulousness at that statement.
Well, finally, okay. One more paper, then we'll move on. This other paper caught my eye. Antigenic drift expands influenza viral escape pathways through recalled humoral immunity. Okay? So recalled, is that memory?
Yes.
Why don't you call it memory? Is this an immunological thing that you have to have different words, or?
I'm going to punt on that one and say the editor made us change the title of that.
Really? Because originally antigenic sin is basically memory, right? And it's just special for flu, but it's memory, right? So what does the title mean? That's really hard for a non-scientist to figure out.
Can you read me the title again?
Antigenic drift expands influenza viral escape pathways through recalled humoral immunity.
So that, again, is from Daniel Maurer. So maybe he should be sitting here fielding these questions instead of me. So what that essentially meant is that as the virus evolves in the human population and drifts, so when H1s, for example, were reintroduced into the human population in 1977, and as that virus circulated in the human population, we made immune responses to that virus as in your lifetime, whether you were exposed through vaccination or if you were infected with that virus. And you essentially recalled every time that you were infected with that virus, a recall memory response, so those antibodies that recognized features of that virus that was conserved from year to year to year.
A giant assumption that the immune system is making memory to conserved epitopes on specific pathogens as opposed to trying to generalize across all the molecular signals that it sees and targeting specifically those epitopes associated with damage or toxicity. And so again, this is just a spectacular list of assumptions upon which we did these experiments. And that's how virology works. That's how a lot of molecular biology with this aim is done. The assumptions are, the list is so long, it's really hard to codify all of them.
Even as the virus was drifting. And so what the paper was looking at is how does that recall response actually influence both the evolution of the virus, but then also are there many antibodies that by targeting the influenza hemagglutinin could potentially, now I've even lost my train of thought. Let me start over there. So the point would be that as the virus is drifting and it's recalling that memory response, that the virus is finding many more opportunities to escape that.
Think about the amount of anthropomorphism that's going on here, where the virus finds ways to escape. The virus is acting on its own. The virus has all these mechanisms that have no basis in reality. You're not making a cuckoo clock make toast. There's no way in hell these signals are outside of us and are trying to, attack us. These signals are not coming from somewhere else. And therefore, you can't speak like this about them. And yet they have all accepted it. Not as a background signal that could be generated from a wide variety of sources that might also be generated by our microbiome or interact with it. They're not talking about the possibility that we could be looking at a very complex bacteriophage. They're not talking about anything. They are assuming that this little package includes like 3 DNA plasmids and a couple enzymes, and they always get it right. And it's just ridiculous amount of assumptions. And then they look at the evolution of it as if they're getting some kind of high fidelity signal for which they have enough background knowledge to know exactly what's happening, when they never do. The whole premise of his paper is layers and layers and layers of assumptions. Somebody like Joshua Lederberg, if he could be awakened and forced to speak honestly, would probably lambast this person as a snake oil salesman who couldn't rationalize his way out of a wet paper bag.
Humoral response. And so it's actually doing a disservice to have that memory recall, and that what we'd want to do is actually to stimulate new responses that aren't relying on the memory recall from those previous exposures.
I just remembered who he reminds me of. Terry Dermody.
Who's Terry Dermody?
You don't know who he is?
I know who Terry Dermody is.
Okay, look him up. You got a similar.
Yeah, I think what Houstonic Live in the chat says is something very close to the infectious swarm idea, and the idea that a swarm of viruses is actually a collection of genetic backgrounds and variations and reassortments, and that the virus acts as an average of that. I'm not really sure I like that, because that's really, really, really close to what this guy would argue is the fundamental phenomenon of life. And so that would also kind of mean that a lot of the signals that we have in our own bodies would be signals that can only be detected on an average. And to a certain extent, yes, that's true. But then we're not thinking about it like the antibody diversity generating mechanism, but we're thinking about it like a noise mechanism. And I'm not sure that noise is built into protein function. I'm not sure that we should consider that. I like considering that idea. But I like to think that there is something a bit more substantial to it, simply because from a person to person to person, from structure to structure to structure, there's an awful lot of similarity if you cut me open and look inside of me versus cutting somebody else open and looking inside of them. And that similarity has a lot to do with where proteins are, what proteins are doing, what proteins are interacting with what, and what proteins are combined with what other proteins. And so for me, that's evidence of a consistently read out plan that doesn't rely on sort of shotgun targeting of a function, where the virology people have you believe that a shotgun sort of display of genetic variants can be summarized by a consensus sequence that can be thought of as the net effect of the virus. And while it's a very enticing idea, it is an idea that stems directly from these physicists who can only understand the world in that way if they are stuck with physics and chemistry. And so I would suggest that by definition almost reveals it as a shortcoming, because it's not taking into the account that life is an emergent property of physics and chemistry, and therefore all the properties of life emerge from life. They don't emerge from the physics and chemistry that upon which they are presupposed. That's the trick. Emergent properties cannot be understood from their components. And if the components of life are physics and chemistry, then we can't understand any of the emergent properties by understanding physics and chemistry alone. And that's really, this book suggests that we can understand life because it comes from physics and chemistry alone, rather than what I would make the argument is kind of what Buckminster Fuller was trying to say, is that a pattern integrity and its emergent properties are foundationally built from physics and chemistry, but they emerge as properties of life itself. And so that's the trick here. And these people are talking about a molecule or a set of molecules or a collection of molecules that can be summarized as an average or a consensus, and that the biological effect is what we see is the result of that consensus despite all of this noise. And although I understand that noise can often be informative, and I'm a neuroscientist and a neurobiologist, so I know that there are a lot of contexts in information where noise can be informative or useful. But in the case of molecular expression and the case of thinking about heredity, I don't think that's quite where we want to go as a foundational principle. But anyway, that's just me talking off the cuff here. Interacting with the chat. Is it playing still, or is that the end? That might have been the end. Oh no. Sorry, I'm going to escape. Here we go. Play again.
we want to weigh in, they can. No, but in general, my research program has largely been centered on using protein engineering as ways to tinker with proteins in order to kind of direct or redirect the immune response to understand how we respond to pathogens, in particular viruses. That's what we focus on. And so what I'm very interested in trying to understand is what is the way that our immune system...
Do you remember? Did you hear that? All phyla. What do you think about that? All phyla.
Do I have to answer every question you ask me?
It's okay.
No, I agree with your incredulousness at that statement.
Well, phyla. Okay. One more paper, then we'll move on. This other paper caught my eye. Antigenic drift expands influenza viral escape pathways through recalled humoral immunity. Okay? So recalled, is that memory?
Yes.
Why don't you call it memory? Is this an immunological thing that you have to have different words, or?
I'm going to punt on that one and say the editor made us change the title of that.
Really? Because original antigenic sin is basically memory, right? And it's just special for flu, but it's memory, right? So what does the title mean? That's really hard for a non-scientist to figure out.
Can you read me the title again?
Maybe we did watch it to the end.
Recall memory response gluten and could potentially I've even lost my train of thought. Let me start over there. So the point would be that as the virus is drifting and it's recalling that memory response, that the virus
I didn't
is
see it
finding
before.
many more opportunities.
There's a huge red flag here. I'm sorry, but anybody that wears their watch like that is an idiot. That's just a statement, and it's the truth. You know, it's kind of like dogs and cats, like you either accept the truth or you don't. Shout out to Kara and Jeff in Canada. Anybody that wears their watch like that's an idiot.
Escape that humoral response. And so it's actually doing a disservice to have that memory recall, and that what we'd want to do is actually to stimulate new responses that aren't relying on the memory recall.
So that's funny because, again, this reliant on new responses and trying to get new responses out of the immune system is suggesting that there's a regulatory element that they don't know about yet. It's suggesting that this progression of immune memory could be reset and then generated again and reset and generated again. Maybe not that dissimilar to how enzymes might evolve over the course of your lifespan to do different things at different times, or to have different, enzymatic properties at different times in your life. All of these things could potentially be happening under the same script and the same genetic mechanisms by which the infinite diversity of antibodies is generated. And yet these people are hyper-focused on it as if it is the only place where this genetic diversity generated by splicing and somatic mutation could occur. And that's just absolutely absurd. You just got to think on longer timescales.
From those previous exposures.
I just remembered who he reminds me of. Terry Dermody.
Who's Terry Dermody? Oh.
You don't know who he is?
I know who Terry Dermody is.
Oh, I know who he is. No, you didn't. You didn't know who he was. Okay, so we're going to start this this David Baltimore interview. Remember, I believe that we are under a spell, and the spell is Donald Trump and the Democrats and all this other crap all around the world. This competition with China or not, and Russia or not. It's all the Human Genome Project, ladies and gentlemen. The main thing that everybody's concerned about is taking advantage of the existing population and collecting the data as fast as possible so that it's not lost. Everything else is smoke and mirrors. They've only got a few more decades.
This is the 150th anniversary interview with David Baltimore. And let me start by asking where you were born, where'd you grow up?
I was born in New York City. I grew up largely in Great Neck, New York. Went to Great Neck High School and Swarthmore College.
Tell me a little bit about your family.
My family were sort of middle-class people, coming from actually quite poor background in New York. My father never went to college. My mother went to college, graduated from NYU, actually was a great scholar in her time, a great student, and went back to school.
Now, one of the things I want to point out here is what I mean by he never teaches is that he never explains anything. There's never any insightful explanation from the guy who supposedly figured it out, where, you know, like, for example, when you read the book that is supposedly written by Kary Mullis about how he figured out PCR, there's some level of amazement and sort of humility in terms of what he found and how he was lucky enough to find it. And you'll often find that missing from David Baltimore's demeanor.
She graduated about 1930 and went back to school in 43 about, after my brother was born, and became an experimental psychologist, taught at the New School for Social Research in New York, and became a tenured professor at Sarah Lawrence at age 62.
Good for her. Were there any particular influences or events in your childhood that you think helped to shape your career path?
Absolutely. Between my junior and senior years of high school, my mother had told me about and I applied for and was accepted at a program at the Jackson Memorial Laboratory in Bar Harbor, Maine, where high school students came and learned a little about research and learned a little about genetics, and lived together as a group of 27 students or something. And I discovered research science that summer, and I never looked back.
Had you been interested in the sciences up to that point?
Well, I was a good science math student. My mother recognized that. I didn't have any passionate interest in a particular kind of science. I had the sense of accomplishment of having really positive feedback from doing very well in the courses and understanding it very easily. But this summer just transformed me.
What do you think it was about research?
It's funny he doesn't have any specifics about that. It just was a summer camp and it was awesome. I mean, it was awesome. And then he repeats it again. The summer camp and it was awesome. You'd think he'd have one little anecdotal thing, where he's like, I just realized on that weekend that everything has DNA. And so that really fascinated me and started to make me believe that maybe DNA was really important. And that idea really got set in my head at this summer camp. But did he say that? No, he did not. That's why he's not teaching right now. He's staying safe. Remember, if you tell the truth, there's nothing to remember.
That kind of flipped that switch?
Oh, I think it was the ability to discover things that nobody else knew. And, it's easy, actually, to do that. And when the faculty there presented me with certain opportunities to study this, that, or the other thing, and I did that, and I found an answer. It wasn't terribly important. I can't even tell you much about it now. But it was something that no one else knew. That just captured me as a way of life. And I've been doing it ever since.
Wow, that is
what
not
made you decide to go to Swarthmore?
A mixture of things. The connection to the School of Psychology that my mother was involved in, the Gestalt School, which was centered at Swarthmore and the New School. The school in exile from Germany. And
is that the same school that Alex Karp and Peter Thiel went to Germany to study? Like the same idea? Am I wrong there? I mean,
and so she introduced me to faculty there, and I knew them. I had also at that summer program met a number of people who were going to Swarthmore, one of whom I later shared the Nobel Prize with. Howard Temin.
You were fated to cross paths.
We seem to have been fated.
So So you started out majoring in biology and then you switched to chemistry. Can you tell me a little bit about that, why that happened?
I switched to chemistry for logistical reasons. First of all, I had a chemistry minor anyway and enjoyed chemistry. But the chemistry department at Swarthmore had some younger faculty and faculty who really understood the desire to do research, whereas the biological faculty was, somebody recently said Swarthmore at that time had a great 19th century biology department. It was much more observational, interested in embryological problems and developmental problems, but not in molecular biology or not in biochemistry. And that's what I cared about.
Embryology and developmental biology. Keep that in the back of your mind, is what was the biology program at Swarthmore, so he chose chemistry.
So I found my soulmates in chemistry, and they said, why don't you switch into chemistry, and then you can do an experimental thesis. It's all about doing experiments. And I did an experimental thesis at the University of Pennsylvania, actually, which they set up, the connection which they set up for me.
And what was the nature of that?
I was studying the the equilibrium of ATP hydrolysis to either to AMP or to ADP.
That sounds like mitochondria, studying mitochondria.
And the issue was how much energy, what was the energy differential between those two reactions?
Okay, not surprisingly, that doesn't mean a lot to me, but I'm...
You asked.
Yes, I did.
Wow, he's such a dick.
Did you have in college influential mentors?
Well, the professor of chemistry, Gilbert Haight, was a wonderful mentor. Pete Thompson, a younger professor of chemistry, was. But aside from that, not really.
Okay. George Streisinger at all?
Oh, well, he wasn't at Swarthmore.
Oh, he was later.
He was at Cold Spring Harbor, and between my junior and senior years of...
So he was a chemist, you see? So he is exactly from the same school of thought that chemistry and physics are going to be able to explain life, and that emergent properties of life are just explainable by chemistry and physics, and by definition, if it's really an emergent property, then that's not happening. Can anybody confirm that we're still good here? I just saw a flash on my screen. I don't know if we're still live and everything. So he's really from this school. And of course, he's going to confirm that in a little bit. Thank you, Jason.
College, I went to Cold Spring Harbor. And that played another central role in my life, partly because of George, whom I worked with that summer. And just the exposure to the greatest biologists living, who all came to Cold Spring Harbor in the summer.
So tell me a little bit more about what you did there.
I was part of what was called the Undergraduate Research Participation Program, ERP. And this was the first class of ERPs at Cold Spring Harbor. It was funded by the National Science Foundation. And I grew up, as I said, in Great Neck. Great Neck is not far from Cold Spring Harbor. And so one April vacation where I was home, I went out to Cold Spring Harbor and made contact with a couple of faculty there whose work I'd read about, because I wanted to ask them to come to Swarthmore as speakers, and I wanted to get some materials that we could play with in the laboratory at Swarthmore. And one of those turned out to be George Streisinger. I had not heard of him before, but somebody directed me to him. And George said, well, if you'd like to, you could come here for the summer as an herb. And I said, I would like to. And I had some other plans for the summer, and when they heard that I had the opportunity to go to Cold Spring Harbor, they said, go. And so I went, and it was an incredible summer. And it's just because Cold Spring Harbor was the center of this very nascent field of molecular biology, and we're now in 1959.
You you see,
most of the work that's in this book was done before 1959. So he kind of came in after all these guys were retiring. He's going to refer to a couple of them, but they were already well into, emeritus status by then. And so he's kind of a guy who maybe even got recruited to sort of take over the narrative of what they accomplished, because he is going to move on to animal viruses. Screw the bacteria and bacteriophages that all these guys are working on at Cold Spring Harbor. Screw that. I'm going to go into animal viruses. That's what he says.
Seem to wind up in the, places. Your timing's good.
My timing, I don't know. But I lived through the right times, and.
So what made you think about MIT for graduate school?
In that summer, two people, Salvador Luria and Cy Leventhal, both relatively new faculty at MIT, were, as I said last night, trolling for graduate students to start a program of graduate education in molecular biology. And they saw me, and maybe they talked to George, I don't know, and said, would you like to come to MIT? And basically I didn't apply anywhere else. I just came to MIT because I'd been invited. And there weren't many places to go to get an education in molecular biology in 1960. You could go to Rockefeller, which is where I ended up, but didn't really want to go directly there. You could go to Caltech, but I was...
So he was kind of in the perfect place to be recruited at the start of the Human Genome Project to make sure that the narrative could be controlled. It's like they all crossed that. And what's weird is that he started the Whitehead Institute, the place where Mark Lander and Francis Collins and Kevin McKernan all worked. Well, Francis Collins maybe didn't, but he was at NIH.
An Eastern person, and the thought of going to California might as well go to Japan. I just had never been there. My parents had never been there. It wasn't part of a world I knew anything about.
So he's going to explain it, but think about this. This is only 50 years ago, ladies and gentlemen. And we have been bamboozled to believe in that 50 years we've gone from barely even being able to go to California without having to stay for a few months to believing that we are on the cusp of being able to genetically engineer humans, which is just a lie. It's an absolute lie.
I probably would have enjoyed going to Caltech, actually. And that's where Howard Timmon had gone. But air travel wasn't so easy then. When you went to California, you were in California. And what do I know from palm trees? So.
It's just around the time jets were starting, wasn't it? Yeah. Do you remember when you got to MIT, what your first impressions were?
What were my first impressions? Well, I was only here for a year as a graduate student, and then I went to Rockefeller. During that year, a number of the faculty were really very helpful to me in thinking through what I wanted to focus my attention on.
Very helpful.
And I decided what I wanted to focus on was animal viruses. And I went to Cy Leventhal and said, I've been thinking that maybe animal viruses could be a probe of animal cells the way bacterial viruses had already been a probe of bacterial physiology.
It was his idea.
And molecular biology. And he said he thought that was an interesting idea. He'd been thinking about that, but he had no idea what to do about it. And I went to Salvador Luria, with the same question. And Luria, who had written about animal viruses in his textbook in virology, and was one of the very few people in the phage world who understood that there were other kinds of viruses and that they could be useful to think about.
Interesting, right? That there's only one guy who understood that concept. Out of that whole group of people that trained under Max Delbruck, there was only one guy that understood that there were animal viruses. that cared about there being, and think about what he just said there. It's almost like it's a myth.
He set me up to work the following summer at Luria with the same question. And Luria, who had written about animal viruses in his textbook in virology, and was one of the very few people in the phage world who understood that there were other kinds of viruses and that they could be useful to think about. He set me up to
think about that statement, that he was one of the only people in the phage world that understood that there were other viruses worth thinking about. It's almost like they had no real biological presence or effect, but we should think about them. I want you to hear this very carefully because I do not think that this is a real story about intellectual progress. I think this is it's a recounting of a mythological intellectual washing away of the lack of evidence for animal viruses and the sort of distortion into everything's an animal virus, and bacteria and bacteriophages don't matter at all in the context of understanding animal viruses. That's his main shtick.
Work the following summer. It's always in the summer when things happen. At Albert Einstein with a man named Phil Marcus, and to take the animal virus course at Cold Spring Harbor. So I went back out to Cold Spring Harbor in August of 1961. No, 1960. Yes. No, 61. Has to be 61. And took the animal virus course. And there I met a guy whom I decided I wanted to work with, Richard Franklin. And he was a professor at Rockefeller. So I scrambled to get admitted to the Rockefeller program. Luckily, there was a guy who had dropped out of the program, so they had one slot open, because it was a very small program. And it was all onesies. But this guy decided he wanted to play cello, as I remember, and not do biology. So there was a slot, and Luria helped me get into it, which was, just the most wonderful thing he could have done, because he had worked hard to get me to MIT, and it was being very successful. But he recognized that I had found what I wanted to do. So I went to Rockefeller, and I did my thesis actually in 2 years at Rockefeller, because I walked into the most incredible scientific opportunities.
Was the Rockefeller...
In Dutch, you say you're falling face first into the butter if you walk into all these scientific opportunities. That's not what happens. That's also not what happened with Elon Musk. He didn't walk into all these business opportunities because he's really smart and put the right people in the right places or spent the right money on the right phone calls or the right trips in person. He is a scripted clown, and I'm sorry, but this guy is a scripted national security actor and was central to laying down this dogma of molecular biology that is a farce. I don't know all the details of the farce, but I will dedicate the rest of my life to figuring it out. I'm excited.
Institute's
it's good to have a reason.
Did it have a different feel than MIT?
Oh, totally different. MIT is a big teaching institution. Rockefeller is a research institution that had a few boutique graduate students whom they pampered. We were just delightfully pampered, and had the opportunity to live in the middle of New York. And by that time, my parents lived in Manhattan, and so it was great. I could sort of cross down from them.
So let me go back to MIT. Was there, in the year that you were there, were you able to sort of characterize the culture or the students or the faculty in any way? Did you have any impressions of what it was like as an institution back then?
Well, you know, as a first-year graduate student, you don't really know a whole lot about the institution. And MIT was very siloed. So I knew about biology and about the biology people. I didn't even know much about chemistry, and certainly didn't know much about what else, other things that went on around. Although sometimes I would wander the halls and find people playing computer games. And that was amazing to me because I didn't know anything about either computers or games, or that kind of game. But you know, like at 2 in the morning, they'd be playing these games in the halls of the physics department.
You came back to...
But let me say that the MIT at that time was just on a cusp of going from a school that had no real biology, it had sanitary engineering, it had physical developments like the electron microscope, it had some neurobiology, Frank Schmidt had done that, but it had, over the period from about 55 to 60, had brought in faculty in biochemistry, biophysics, molecular biology, and was really shaping itself for the future. And it was terrific. I mean, Alex Rich, who's still here, Vernon Ingram, who I think has passed away, Salvador Luria, who has passed away, and others, were really creating a unique department here. Unique in the sense that it didn't have the antecedents of zoology and botany that so many other schools had. So it didn't have that baggage to worry about. On the other hand, it also had absolutely no organismal material to work with. So it was all biophysics, biochemistry, and molecular.
Hear him saying that, right? The baggage of having a zoology department or a biology department wasn't really there. So it was really nice. But we just didn't have the animal material to work on. It's almost as if it's remarkable. Like, it's such a bunch of bullshit.
Biology, which molecular biology is hard to define, but we'll just leave that alone. And the faculty was very interested in the development of the students because the students were all people who were pioneers, because there wasn't an established curriculum. Nobody even knew what they ought to do. I ended up a biophysics major just because that seemed like stuff I ought to know. And I passed my prelims in the first year.
So I was a biophysicist for about 20 years. And one of my main focuses for the first training of that biophysics part, where I was actually doing biophysics, was patch clamping recombinant SK channels and recording from large quantities of them to get accurate readings on their average kinetics. And so I was a biophysicist. I've read biophysics for a long time. And so he is being very general. Because he says that molecular biology is hard to define, so he won't do that here. But 10 minutes later or 5 minutes later, he's talking about biophysics as if it's a field that doesn't need any clarification. You can just be a biophysicist. Bullshit. If you didn't work on ion channels, then what did you work on to qualify you as biophysicist?
The year that I was here in biophysics. But that was just convenience, I guess.
Ha!
No this might be a good time for you to talk a little bit about where the first Nobel Prizes at MIT were.
The first Nobel Prizes at MIT.
So she's reading a script, right? This might be a good time for you to talk about those. So a couple times he got caught off guard there, and it was pretty funny how general he talked, how many times he had to drop a name instead of a concept.
Received were in economics and in biology. I think the literal first may have been in economics. Samuelson, they were three, Modigliani and Solo had all won the prize. And in biology, Luria, well, I won it, but that gets us to a later time. But it was all I don't remember exactly when Luria's Prize was. Probably in the 70s. And his was the first. But there were no other Nobel Prizes at MIT. There were no prizes in physics or chemistry, things that you might have thought would have been the first places to be recognized, because MIT really was set up as an engineering school, and everything
That's
else
correct.
was sort of ancillary.
The term hacking comes from the MIT Train Club, as far as I understand. They had a really, really interesting train club there.
To engineering until after World War II, when there started to be a real thrust in basic science at MIT, as near as I can tell it anyway, at MIT. I have a real mirror to that, which is Caltech. Caltech was set up to be a school where it was also an engineering school, but the engineering was set up to be a derivative from the science. And so Hale, who really set the template for Caltech, said we have to have strong physics, strong mathematics, strong biology even, and strong chemistry and strong biology from the very beginning, and that they are going to feed into the engineering disciplines rather than the other way around. And so Caltech was never a sort of build a bridge engineering school. But Caltech started winning Nobel Prizes in the 30s. I think the first prize was about 30. Well, it was early in the 30s. And Morgan, who won the Nobel Prize in biology for his work in genetics, was then at Caltech. Carl Anderson was the first one to win a prize for work actually done at Caltech, and that was in the 30s. So it was a really very different mindset between MIT and Caltech. Hale, I might say, came from Caltech, got his degree, came from MIT, got his degree here, and was once invited back to be president and said, no, I want to be in Pasadena and I want to build a school on somewhat different principles here, and then stole the chemistry professor from MIT, Noyes.
So after you finished your doctorate, you came back to MIT.
That's right.
Tell me a little bit about that.
So as I said, I did my thesis in 2 years, and Rockefeller said, we have a 3-year residence requirement, and but there's clearly nothing else you need to do. And anyway, my professor had left Rockefeller to go to Colorado, where he got a nice job. So they said, why don't you just be on leave? Because Rockefeller was really, as I say, very focused on its students. And they had a program where if you wanted to go somewhere for a year, you could do that. So I came back to MIT. And meanwhile, MIT had hired Jim Darnell. And Darnell was probably the most forward-looking person working with animal viruses in the United States. And so I wanted to learn the technology that he was applying to these problems. I wanted to work.
Still no details, just names and technology.
Work with him and with the whole atmosphere he had created here, which was really very special. So I came for a year. Actually, I just came as a postdoc. I planned to spend a couple of years as a postdoc. I hadn't really made a scheme out of it. But then Jim left after I was here a year.
See, it's really contradictory in a way, right? Because he's living in a time when moving is not a trivial thing. When moving requires commitment. And sometimes he's like, it's really nice that I was in New York because I could go see my mom on the other side of the city, but I would never go to California. That's like moving to Japan. But now he says he's going on a postdoc, but he doesn't really know how long he's going to go, maybe a couple years. So it's all just feels like a person who's lying and, leaving out details that matter, which is that he is basically a scripted actor who has been part of a program of people that were put in place, whether they wittingly or unwittingly were participating in the beginning. They know at some point that they are maintaining a narrative of bullshit about animal viruses.
And went to Albert Einstein. And so my reason for being here dissolved. So I only spent that year between 63, 64 here. And then I also went to Albert Einstein, but not with Jim. I went to work with a biochemist, Jerry Hurley.
I mean, I want you to think about the idea that people that were physicists that worked on the Manhattan Project and then switched to biology started with bacteria and their phages. And then supposedly, when we discovered that there are also animal viruses, all of them decided to stop working. They weren't interested in animal viruses. Only one of those guys was interested in animal viruses. I mean, that doesn't even make any sense. We are transitioning out of a world that didn't even know about DNA and inheritance, as I played in the beginning with Joshua Lederberg talking about the Avery paper. But now we're transitioning to animal viruses without ever having solved the problem at the bacterial level, even with our best physicist minds on it. I hope you can see where this is going.
Because I really felt I needed some rigorous training in biochemistry. And I did. And it held, I probably never would have won the Nobel Prize without it.
And after that, you wound up going to the Salk Institute?
I did. So I was at Einstein, and Renato Del Becco came through. He was giving some lectures, I think at Rockefeller, actually. And he sort of knew what I had been doing in animal viruses. By this time, I was fairly widely published and known in the field. And my mentor wasn't anywhere near it. Wasn't any better known than I was, so we were seen as sort of two young Turks. And he called me and he said, we're going to set up, he was at Caltech at the time. He said,
He did refer to himself as two young Turks. He did say that.
Made a commitment to go to the new Salk Institute, which is going to be formed in La Jolla. And I would love to have you come as a junior faculty member in my unit. It wasn't really departments in the usual sense, but...
So do you think he crossed paths with Inder Verma and his grad student, Robert Malone? I wonder.
He had space. He could do anything he wanted with it, and he was offering me some of that space to do my program in and working on RNA viruses. And then ensued this wonderful uncertainty about whether the Salk Institute was actually going to exist or not. And I would get these notes from Del Becco's, or calls from Del Becco saying, don't make any plans because I'm not positive it's going to happen. But we're having a meeting next week and I'll get back to you. So meeting occurs next week, gets back to me and says, looks like it's going to happen, start making plans. A couple of weeks later, we're running into trouble. And so this went back and forth until finally he said, yes, it's going to happen. And I got in the car and came out to California, which was, by that time I had once before been to California. I'd flown out there to give a lecture, actually at Caltech.
Not so much of a culture shock.
Well, it was a culture shock. It was an enormous culture shock. And particularly in this sort of unformed world of La Jolla at the time, where they were just starting up the university, and the Salk Institute was brand new, and we were working in these temporary buildings. When I arrived at the Salk Institute, they built labs for me in the basement of this temporary building while the main building was going up, and they had to take a rattlesnake out of the lab in order to get me in there. This was the Wild West.
And so you were there for 3 years, and then you wound up coming back to MIT.
That's right.
And what was the draw?
the MIT yo-yo. The draw was that I loved MIT. I had loved my 2 years here as a graduate student and postdoc. And it was all about Salvador Luria, because while I was at Salk, and I picked up virus work again after my postdoc, and I was publishing some interesting stuff. And a professor at Harvard became aware of it, Bernie Davis, and Bernie said, "Would you come and look at a job at Harvard?" And I said, "I'll come, give a seminar." And so I did. And Luria heard about it. And Luria then engineered an offer to me on the basis of what people knew about me. I don't think I came and gave a little seminar.
It's so crazy because nothing that he's saying is profound. How he's saying it is not profound. The details that he offers are not profound. The stories are not entertaining. It's almost like he's skeptical of the interviewer's motives, even though the interviewer is scripted. I'm going to pick up where we leave off here now tomorrow. I think that endemicity is a myth, and that's one of those myths that the Baltimore scheme hides. And now we have Vincent Racaniello being the foremost authority on the Baltimore scheme. The Baltimore scheme is as nonsensical as using a non-specific PCR test to track something in the background, or the idea that most people were fine after they were transfected, but in reality, placebo made it safe, and it also made it possible to produce billions of doses without breaking a sweat. If you use their test to find their ghosts, you are definitely not a ghostbuster. Ladies and gentlemen, please remember, we've got a lot of work to do. There's a lot of study halls to come, a lot of journal clubs to come as the final touches are put on these couple books that we're trying to do here as a family. Don't believe the red hat shit. Don't believe the blue hat shit. Everything on the shitternet is terrible. Ladies and gentlemen, intramuscular injection is dumb, transfection was dumb, RNA pandemicking is dumb, and autism is a dumb word. Yes, ladies and gentlemen, it's a semantic game. Thanks for being here. I'm sorry that we're trapped in this theater, but I do see a way out. The doors are still open. They'll be open for a few more years. We can get our kids off and we can imagine a world together, and then we can create it together. If you want to, I think it's a good idea to download the PeerTube app and watch on your phone. It's a lot better than the website, but the website does allow you to download the videos and upload them wherever you want to. I encourage you to make your own YouTube version of Gigaohm Biological, streams or shorts or whatever you want to do. I encourage you to do it. And in the meantime, download the PeerTube app, start using it, stream.gigaohm.bio. And Bob is your uncle. Thanks for being here. See you again tomorrow. Gosh, isn't that scary? What the hell happened there? Oh, man, that hurt.